What's poppin', dogs? Mr. Allen here with some evaluation of trig functions using our double angle formulas you see up there. We got if cosine of theta equals 5 over 13, and theta is between pi and 2 pi, so the third or the fourth quadrant, find sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. So these problems actually start out the same way that some old problems started out. When we gave you cosine of theta equals 5 over 13 in the quadrant location, right? We drew a triangle, and that allowed us to evaluate sine of theta and tangent of theta. But now we're using the double angle formulas. Let's start it the same way, though. Let's draw the triangle. How do we know which quadrant it's going to be in, right? Because it's the third or the fourth. Well, since cosine of theta is positive, that tells us that it's in the fourth, because cosine is positive in the first and the fourth quadrant. So I will go ahead and draw this thing here. I got my adjacent side is 5. My hypotenuse is 13, which means that my opposite side is going to be 12. But it's going down, yellow and timber. It's going to be negative 12. Okay, so we got to pay attention to that in here. It's easy to miss that negative sign because my fraction's positive. You don't think about the negative numbers yet. But because of its location in the fourth quadrant, my opposite side is going to be negative 12. And we are always looking at it from the origin here. Technically, my theta would be to the terminal side there. That's my theta. A lot of times we just throw it in the triangle, though. What else? All right, let's go ahead and start evaluating. Shall we? We shall. Let's do it. I'm going to go with the neon yellow first. So I want sine of 2 theta. I like to write down my formula when I do this, right? So I'm going to write this down. We get sine of 2 theta equals 2 sine of theta cosine theta. Cool. So now, what is sine of theta? Well, perhaps another smart move would be to write down what sine, cosine, and tangent all equal, right? Then I can just plug things in. So let's also do that. So I'll write that down over here. I'll even use a different color marker. I'll jot it. Let's see here. Sine of theta. That's going to be negative 12 over 13. Cosine is given in the problem, but I'll put it over here so we're nice and organized, right? It's 5 over 13. And then tangent is going to be opposite over adjacent, negative 12 over 5. Okay, cool. So jotting those down, smart, right? I probably should have just done that right away, but I got ahead of myself and I wrote down that formula. Now we're ready to plug in and just go, okay? Write those guys down, super helpful. So we've got ourselves, let's see here, 2, and then sine is going to be negative 12 over 13. Cosine is going to be 5 over 13, positive 5 over 13. So this thing's going to be negative overall, right? So here, let's see, we got negative 12 times 5, that's negative 60, times 2 is negative 120, over 13 times 13 is 169. There we go. Can't even reduce that thing. Going to leave it as that. So that's sine of 2 theta. Now, we shall move on to cosine of 2 theta. So for cosine, let's see here, cosine 2 theta. We actually can, rewrite this this formula here a few different ways. I'll just use this one. It's easy to work with here. Cosine squared theta minus sine squared theta. But you can use your Pythagorean identities to substitute that in for either cosine squared or sine squared. If you're doing a different problem, you might want a different formula. So it can help to know some of the algebra there and how you can manipulate it so you don't have to memorize so many formulas. Because most teachers are going to have you memorize these. If not, you're one of the lucky ones, but usually got to memorize them. All right. So let's plug in, right? Cosine is 5 over 13. Sine is negative 12 over 13. They're going to get squared. So we got 5 over 13. Then we get negative 12, right? Negative 12 over 13 squared. So that's going to be 25 over 169. We got 144 over 169. There we go. We got to subtract. Here's at 119. Negative 119 over 169. I think that I'm gonna double check it before I like throw this up on the internet and I'm like I got this arithmetic mistake here, right? Negative 119. We're good. Okay, we're good. I should have believed in myself, man. I should have believed in myself. But always good to double check yourself before you wreck yourself. Boom. Lovely. Awesome. Fantastic. All right. Let us continue here. I'm going to circle that bad boy and then we're going to move on. All right. Blue marker, last one. Blue marker. Tangent 2 theta. Let's jot that down. Tangent 2 theta is 2 tangent theta over 1 minus tangent squared theta. You actually derive these fun little double angle formulas from your sum and difference formulas. It's kind of cool. Maybe I'll do that in a different video. I mean, cool, right? In the from the math teacher perspective, it's kind of cool. And when the algebra works out, you're like, oh wow, it really is a thing. Someone didn't just make it up. Well, somebody did, but they figured it out. All right. Anywho, let's continue. We got ourselves. I keep saying we got ourselves. We do got ourselves. Negative 12 over 5 for tangent. And then we have 1 minus negative 12 over 5 squared. Fractions of fractions, man. It is what it is. So we have 2 and negative 12. That's a negative 24. So negative 24 over 5. All over. It's a bad spot for that equals. I'll put it right here. All over. We got 1 minus. And then we have 144 over 25. All right, so I'm going to do a little bit here because I'm running out of room. Actually, I could probably bring this all over here. We'll do this, and we'll work right across. Negative 24 over 5 over, we get 25 over 25 minus 144 over 25. So we got to get that like denominator so you can make that denominator into a fraction. I put my equal sign in a bad spot again. Equals, we'll keep the numerator the same, negative 24 over 5. Here we have negative 119 over 25. That actually works out nicely, right? It's right there for us. Negative 119 over 25. Now I can multiply by the reciprocal, right, for division. That's the official notation for multiply by the reciprocal. It's not official, but I think it works out well. Negative 24 over 5 times 25 over negative 119. So we know it's going to be positive. It's negative times negative. The 25 and the 5 will cancel or will reduce down. And we've got negative 24 times 5, which is 121. So negative 121. Is that right? Yeah. Why did I put negative? We said it's positive. Is that right? Is that right? 120? No, 120. I'm going to double check with the calculator. One sec. Hold on. I'm losing confidence here, man. All right, 24. 24 times 5. 120. There we go. All right, so we get 120 over 119 for our final answer right here. Beautiful. Sorry, I struggled with some of the multiplication there, guys. Man, sometimes it gets you. Sometimes it gets you. You know, you can always do a little side multiplication here just to make sure, but I had my calculator here, and, you know, there's no teacher here to say, hey, it's a non-calculator test. So I'm just making the videos, man. All right, cool. There we go, guys. All right, so we got 3 different scenarios here. Always, always, always draw your triangle. Make sure it's in the appropriate quadrant. Otherwise, things are going to be jacked up. All right, put down your 3 trig functions so you can just plug these fractions in and evaluate, all right? You'll see a lot of the similar numbers coming up here, depending what triple you're dealing with, whether it's the 3, 4, 5 triangle, 5, 12, 13, 8, 15, 17, or 7, 24, 25 triangles, but you'll see similar numbers pop up, which will allow you to get a little better at it and not have to rely on, you know, your calculator here, because a lot of these will come up on non-calculator tests. That's tough, but you can handle it because you're awesome. See you later.